is we're going to actually record what I'm talking about here. So if you want to review, you can go on YouTube. Okay? Or you can go to the website and find YouTube. But if somebody's out, then they can go back and look it up and make sure they're on track as far as figuring things out. So what we're looking at here are some basics of the metric system as they apply to chemistry. Maybe this thing will settle down in a minute. Okay? So you got something to take notes on, I hope.
Can we just keep that quiz?
Yep, because I've already taken the grade. Okay? All right. So usually when I do quizzes, that's what I tend to do. Okay. I either have you guys grade each other's papers, and I come around and check it real quickly. Okay. And I make them really short and easy, or I think they're easy. Sometimes I find out different when I start grading them. But that way you have an instant feedback. You don't have to wait 2 days or something like that for me to get them graded for you to know whether you really understood something or not. And I find that personally valuable for me to know right away whether I know something, and I hope that you also find it valuable in the same way. Now, if I'm explaining things to you, I expect you to take notes, okay? And I shouldn't have to ask you to get out your notebook or your ring binder if I'm explaining something, okay? You need to be mature enough to know that you need to take notes on things, all right? Got it? All righty. So, base units. Let's talk about something called base units. Base units are the units, measurement units in the metric system that, at least the ones we're going to use in here is what we're going to talk about. Base units are the ones in chemistry or in any metric system that's being used that have no prefixes. Okay, so prefixes are like some of you are using centi or milli for the measurement in the lab or the activity we did a minute ago, the quiz we did a minute ago. Well, centi is a prefix. Milli is a prefix. So the base unit for what we did a minute ago was the meter. Okay, so base units include things like the meter, and the meter measures distance. Okay. Base units include grams. We use grams a lot in here. And grams measure, what do grams measure? Not weight, really, because weight is actually affected, what? Mass. Weight is actually affected by gravity. Mass doesn't change. On the moon, it's the same mass as it is here, but on the moon, it's 1/6 the weight. Does that make sense? Now, we often call it weighing when we mean taking the mass, but I want to be clear about what grams actually measures. Grams actually measures mass, okay? If we want to measure weights, there's actually different designations of that, okay? Let's see, we're going to measure volume. And volume, there's a difference between the metric system and the international system of units, okay? The international system of units doesn't use every metric system unit, okay? When we're measuring volume, our base unit's going to be liters, okay? Turns out 1 liter equals a cubic decimeter, and a decimeter measures distance, so it's distance times distance times distance. You can think of it like a cube with 3 sides. I mean, across the front, across the side, up and down. And so that's the international system of units that would be used for volume, cubic decimeters. That's the basic unit for volume. But we're going to use liters. Okay, it's just very common in chemistry, and it's the same thing as a cubic decimeter. Okay, that makes sense? All right. And so let's see, temperature. We don't very often use prefixes for temperature, but there are actually 2 units that are used for temperature in chemistry. It's degrees Celsius, or sometimes it's let's see, centigrade it's called. Okay. And the other unit that's used is Kelvin. Oops. Kelvin. Now notice Kelvin is capitalized and Celsius is capitalized. Generally, the reason we capitalize certain measurement units when we don't capitalize others is the ones that are capitalized are named after somebody. So Celsius was a person, Kelvin is a person. Does that make sense? Okay. All right. So then what we also used for our system of measurements are prefixes. And I only need you to really know and be able to use 4 prefixes in here. Okay? I only need 4 for this class. Kilo, centi, milli, and nano. I may occasionally refer to some others, but those are the only ones I really need you to really understand how to use. Okay? So let's look at these 4 prefixes. Kilo means 1,000 times whatever the base unit is. All right, I'm going to symbolize base unit as BU. Okay? So base unit is BU. Okay, that's just my code over there just so you know what I'm talking about. Does that make sense? Okay. Centi, do I need to slow down for you a little bit? See some of you kind of struggling to keep up. Listen, it's an important skill that you learn to summarize even when you're taking notes, because you can't, well, this is a college prep class. Most of you are juniors, right? Anybody here a senior? No? Anybody not? Maybe a sophomore in here? One sophomore? Okay. So you're getting close to being finished with high school. Okay, if you're a junior, you got one more year. And when you go to college, you can't expect a college professor to slow down for you to take notes. Okay, they're going to keep doing their thing, and you just got to keep up. So it would be a really good thing for you to start practicing. We're in the second semester of your junior year, most of you, and you got one more year to practice taking summarized notes. All right, so it would be a really good skill for you to practice keeping up by only writing down the key things that you have to write down so you can understand. All right. If you try to write down everything in a college class, there might be some college professors that'll slow down for you, but the ones I had didn't do that. Okay. They expect you to keep up. All right. So that's an important skill, and I want you to be successful in college. So I'd encourage you in the strongest possible way to really try to start just summarize it. Okay. Try to figure out how to make that work for you. All right. Does that make sense? Okay, all right. I'm not going to try. I'll try not to leave you behind, but at the same time, it's really important that you try to build those skills. All right, all right. So centi is 1/100th times the base unit. Okay. Another way to write that would be 0.01 times the base unit. Okay. Milli is 1,000th times the base unit. Or 0.001 times the base unit. Okay, here's the fun one. One billionth times 1/1000th of the base unit. That's a bunch of zeros, and we're going to work with numbers that have a lot more zeros than that. So we need a way to make it a little easier to manage. Okay? And the way that's easier to manage when we get into numbers like that is like 10 to the negative 9 times the base unit. Okay? So this is the basis behind something we call the scientific notation for numbers. All right? Does that make sense? So scientific notation would take this number and we'd say 1 times 10 to the negative 9. Okay? That would be the way you would write scientific notation. What now?
So that's negative 19.
Oh, yeah, there you go, 9. Sorry. Good. Thanks for catching me on that. Okay, so if we're writing a scientific notation, you have a 1 there. Okay? If we were going to write it, if we had more significant digits, we put a decimal place in digits after the 1. Okay, we'll talk more about that later on. All right? Got that? Yes? Okay. So let's talk about how to use that then. Okay? What? All right? Let's talk about how to use that. All right? So if a kilogram equals 1,000 grams, if a kilogram equals 1,000 grams, then we can write that as kilogram, 1 kilogram equals 1,000 grams. Then 1 kilogram over 1,000 grams equals 1. Does that make sense? Surely somebody doesn't understand this. Come on, really. I'm waiting for you to tell me. What are you talking about? No, but y'all get that? Everybody does? Huh?
I don't.
Good for you. Thank you very much for speaking up. Good. Pat yourself on the back there. Okay? No, you don't have to, really. I'm just kidding. But, I mean, that's the point, all right? So, here's the thing. If I put a number 2, let me go to another piece of paper here to just kind of illustrate the point here. If I have the number 2 over the number 2, what does that equal? 1. Oh, you know that, right? Well, why does it equal 1? That's because 2 equals 2. So if I have 1 dozen equal to 12, and I put 1 dozen over 12, that's going to equal 1. So anytime I have 2 things that are equal, then if I put them in a fraction like that, it's going to equal 1, right? Okay. So that equals 1. So 2 does 1,000 grams over 1 kilogram equal 1. Does that make sense? All right. This is the basis for all conversion units. Anybody here in JROTC? A couple people. What is a unit in the military?
A rank of people.
Huh?
A rank of people.
A rank of people. When you say rank, you don't mean all sergeants, do you?
No.
Okay. There are a group of people tasked with, or who have been given the same task. Okay? And it could be 1,000,000 people or it could be 3 people. Right? So a unit means one task.